Okay, this how-to video is going to show you how to use the power inductance workflow capabilities inside of the Cadence PCB tools. So you would need a Sigrity kind of Aurora based license or some Sigrity tokens to be able to run these actual simulations, which you can run from within inside the Cadence PCB tools, or you can get an SI engineer or an external company to run these simulations for you and then give you the files, and then you can actually load them into PCB Editor and see them. So that's what we're going to show today. So if we go to the Analyze and Workflow Manager, if we look through the selectable workflows, we're looking for power inductance. I can then effectively then load the analysis results, and I've got this this power inductance file with the relevant other files that get stored with the simulation. So as we open this up, obviously we get a vision view that we can physically see, but let's go to the tables first and have a quick look and just go through some of these. So we can kind of expand the tables out. We can see the different voltages and then the different capacitors and what the inductors are on all the different capacitors. And we can obviously sort these by inductance, so you can physically see these, which is the highest inductance. So I've got maybe an issue potentially with C139. C105 is okay, and you can just work through each net individually or and work out where you need to go, but quite a good indication of the graphics of what's going on. What we'll do is we'll turn the tables off, and then if we look at the actual visions, now by looking at the visions, what we can do is we can choose the voltage that we're interested in. So if I was to look at say 2.5 volts, for example, I can then see the color coding for all the different capacitors in my design that are decoupling, and then obviously I've got a change in inductance based. So if we have a quick look in here, obviously I've got a row of capacitors. So what's going on here? This end seems okay, this end there's an issue. So the easiest way is if we just turn the vision off, and then we'll just turn maybe the bottom layer on. You can see that this end, all of these capacitors effectively have their own individual via going down into ground, whereas this one, they're sharing a via. So that's potentially going to be an issue. So we might need to add some individual vias for all of these decouplers to kind of resolve that inductance issue. And we can kind of do that on all the different, if we go back to the visions again, maybe let's have a look at the 3v3. We've probably got something similar up here. And if we just we'll turn on the layers, you can see effectively I've got just a single via for both. So the issue is obviously from the 0 volts, this capacitor is probably a bit too far away from this via to have any decent inductance, and that's why the inductance is increasing. Quite a useful workflow to be able to kind of visualize what's going on in the design, and you should be able to solve any kind of these type of issues before you actually send the design out, because you've got the analysis here.